bad. It's a pretty short section. 6.5, so we got one more section left to teach. Properties and applications of matrices. So we're going to basically do two things with this. We're going to add and subtract matrices, and then we're going to do scalar multiplication. There's also a thing out there called matrix multiplication that's also in this section that we're not doing. So we're not doing matrix multiplication. We're only doing the scalar multiplication. So like they're saving you a bit there with this section. And so we have this section. Next Tuesday, we're going to have a sort of review, and then next Thursday will be your final. And so what I want for next Tuesday is you to go find your old test. So I guess the first thing you need to do is find them. And the second thing you need to do is look over them a little bit. If there's anything you don't know, like why it's marked wrong for whatever reason, like come with questions on Tuesday about that. And I guess that's it for everything that we've been doing. I haven't graded tests yet. I will get those graded pretty quick. It's like make your final, and then I'm just gonna like be grading for days on end. Probably is what's gonna happen. Okay. Are there any questions over anything we've done? Anything that's like planned for the future for the final? Okay.
Yeah, are we gonna have a quiz for the final?
For the final, no, there won't be a quiz. It's just kind of like study your old test.
Okay.
Yeah. And so the final is cumulative, so that means it's going to go back through everything that we've kind of done. But like my best suggestion for it is to study your test. That's kind of like where I'm pulling the questions from. So it should look kind of similar, hopefully. I'm not trying to like do anything tricky. Okay.
How many questions you think there's gonna be on it?
I'm going to try to narrow it down to around like 20.
Okay.
Okay, so I think we'll start on this then. Properties and applications of matrices. So the matrix notation, so it's basically what they do is for each element in the matrix, this would be like a matrix called matrix A. So maybe if you want to write that, we would call the matrix a capital A. We would call each element in that matrix like a lowercase. And then the subscript tells you the row and the column. And so this is the first row, first column, second row, first column, third row, first column. Same thing, right? It's like first row, yeah, first row, second column, second row, second column. And so if you notice, like the ones in the diagonal, maybe they have the like same number. It's the same row, same column. I don't know. What else can we observe? A general element is denoted by A sub ij. Ooh. Try to say that 5 times fast, I think. A sub ij. So this refers to the element in the ith row and the jth column. 2 m by n matrices A and B are equal if the corresponding elements are equal. So for two matrices to be equal, like there's really kind of two things that they're saying with this definition. First is like they both have to be the same size, right? That has to be the same rows by columns. And then the other thing is each corresponding entry has to also be the same. And so if we're looking at this, they give us an example one, and I'm kind of horrible with this row kind of column notation. I will flip those if I'm not careful. But A12, I believe is this one, was the minus one. This is A12, this is A21. Okay. B32, and if you want, what I'm kind of doing is looking up and looking where it would be. That would be this one. I'm hoping you can look at the table, like pick out these numbers. B22 would be that middle one, which is what, 6? So they can ask us what the number is, or we could do some calculations with these numbers. So A11 is 0. We're going to multiply that by 0. And so I did it without really saying it, but this A came from this A, these B's came from this B. And so hopefully your variables are matching each other there. Your matrix is also the element that those two things are the same variable. So A12 is -1. B21 is this 2. A13 is 6. And I'll multiply that by B31.
Wait, isn't B32 -1? Like, where do you see -2?
B32 would be the third row, second column. Is this the one you're talking about?
Yeah, I thought.
Yeah.
Okay, never mind.
Were you going the other way? That's what I do. I always flip them. I'm horrible with it. So if this is like the thing that you're like freaking out on, like I wouldn't freak out too much on this because
Okay.
one of those things, like if I'm horrible at it, and probably not gonna ask you too many questions on it, right? 6 times 7, I believe, is what I'm doing here. Minus, so I believe minus 2. I believe it's gonna be 40. Oh shit! I didn't even pull up my key. Let me do that right quick. Okay. Is that what I got in my key? Yeah, I got 40. Is it possible to find a value of x that makes these two things equal? Okay, so one thing you might want to say is like, well, x looks like it could be 6. Okay, well, if we did that, whew, that is blurry. Come on, focus. I don't know why you're not. Yeah, it doesn't want to focus today for some reason. Okay, so if you said something like x is 6, well, if we come back and look at these, there we go. Now it's doing it. Okay, so if we come back and look at these, okay, x is 6 here, x is 6 here, but then like the thing that maybe is a little tricky with this one is that we got like a 9 here and a 7 here. And so even if we let x be 6, it doesn't fix that problem. So if possible, find an x value that makes x a equal to b. Well, this isn't going to work, so it's not possible. And again, it's like not possible because 7's never going to be 9, right? Even if we let x be 6 here, it's not going to solve this problem. And so they are the same size, so that does check off, but not the corresponding entries, right? The corresponding elements are not the same. And there's no way we're going to make them the same by setting values of x. Okay. So that was a sort of like basis, like how do you read how do you read a matrices, and how do you like label the elements within the matrices? And so I guess we also introduced that it goes n by n, the dimensions of the matrix, but I've already kind of talked about that previous section. So now we're going to talk about some actual operations on the matrices, some sums, differences, and scalar multiples of matrices. Okay, so to add two matrices of equal dimensions, add the corresponding elements. To subtract two matrices, subtract the corresponding elements. And if you try to do two matrices that aren't the same dimensions, it's not defined. So we call that undefined. We don't do it. We just say it's undefined. So we look at something like this. We do A plus B. So maybe I'll do a little matrices in here. But this first element looks like this first element plus this first element. All we're doing is 4 plus the 3. We're doing the -1 plus the 3 over here. These sort of things, if they're A11 gets added to B11. A12 gets added to B12, right? Is this sort of pattern that we're doing here. And so it should be, this is a rows by columns, this is a 3 by 2 matrix. We should end up with a 3 by 2 matrix in the end. So this is 4 plus 3, this is 4 plus 1. 2. Now I'm doing a -5 and a 0. I'm doing a 0 and a 4. Minus 1 is 2. This is a -5, and this is 4. So I did A plus B. I wrote out this middle thing. Yeah, I don't really expect you to have to write out that middle thing all the time. If you just want to write out your two matrices, I think you'll probably see it as well. B304. So now I'm doing the B part, and this might seem kind of silly. But if you can just look across and do 3 plus 4, that's 7. If you can do 1 plus 4 is 5, minus 2, and that is going to give me -1. 3 minus 1 gives me 2. And I know this might seem kind of silly because this is the same thing we were doing up there pretty much. And so, but they're trying to get at a certain point here. And the point is something that we've completely thrown out now that we don't do matrix multiplication. But it doesn't matter whether we add these A plus B or B plus A. We can add them either order. Whether we do 4 plus 3 or 3 plus 4, we're still getting 7. And I've talked about this before, but it's like the way they're arriving to the problem. I look at these things as like they're commuting to the problem, and it's the way they're arriving, so that is the commutative property. Okay. So I'm doing A minus 2. And so really there are two different ways you can sort of do like the subtraction. So you could look at this as sort of like being like parentheses of distribution, and this being a negative. So you can distribute the negative and then add, sort of like what we do with distribution, or you can just subtract. So 4 minus 3 is going to give me what? 1. 4 minus 1 is going to give me 3. 1 minus a minus 2 is going to give me 1 plus 2. It's going to give me 3. This is a -1 minus 3 is going to give me -4. This is a -5, and I'm not subtracting anything. Still a -5. 0 minus 4 is going to be -4.
For the 0 minus 5.
It's -5 minus 0.
Minus 5. Because doesn't the 0 go first and then a minus sign and then the -5? Or am I just,
No, the -5 is coming first. This is the first thing, -5, and then we subtract 0.
Oh, A from, okay, thank you.
Yeah.
Sorry.
If you did it the other way, it would become positive, right? And I'm going to do it right quick. I'm going to do this the other way that I was talking about. So if we want to distribute this, it gets distributed everywhere here. This is negative, negative, negative. This is positive. Then where we get the same answers. So if you want to distribute that negative and make it an addition, you can do that as well. Like that is a valid thing to do.
Thank you.
And so we've done that. We've done that with distribution as well. It's like a sort of distributive sort of thing happening there. But now we're talking about like multiple levels happening, right? There's multiple sort of entries there. Okay. Oh, happy days. Look at that. I think this is the Fonz's favorite problem. It's like okay. And my phone's beeping at me for making that joke. Okay, so 1, 2, 3, 4, 5. There are like 5 of those things there. If you wanted to, you could write out this matrix 5 times. And so I don't want to do that. I'm straight up lazy. I don't want to do that. So what do I do instead of doing that? Okay.
Multiply by 5.
Multiply by 5. That's exactly what we do. And so this is what I'm trying to do here. I'm trying to introduce scalar multiplication. And so we're doing this 5 times. So you could write the 5 outside of the matrix. You could write the 5 on the inside of the matrix. 5 times 4, 5 times 4, 5 times 1. Multiplying each entry by 5. Make sure I get all those numbers right. Okay. Yep. Okay. So now do it. 5 times 4 is 20. 20. 5 minus 25. 0. So I'm running out of room over there. But it's there. And so this is what scalar multiplication is. And a little side note, this is not the same thing as multiplying matrices. If you multiply matrices, it is completely different, and we're not doing that. So don't like fret over matrix multiplication. It is a more complicated thing. You have to multiply and you have to add when you do it. It's the whole step of operations. It's not super hard, but it is more, I guess is what I'm saying. So this basically says the thing that I just said. Every element in a matrix is multiplied by a real number is referred to as scalar multiplication. And so now we're doing this. Now they're giving us a matrix. A equals this thing. We want to find out what minus 2a is. And so literally what we're doing is we're taking minus 2 and we're multiplying it by each entry in this matrix. So I think I could probably skip the middle steps of writing those matrices. I'm getting tired of drawing these big brackets. Okay. So if I do minus 2 times 2, that's going to give me minus 4. This is going to give me a positive 6. This is going to give me a positive 2. Minus 2 times 0 is going to give me 0. Minus 2 times 3 is a minus 6. Minus 2 times minus 4 is a positive 8. Minus 2 times minus 1 is a positive 2. Times a minus 2 times 6 is a minus 12. Minus 2 and minus 3 is positive 6. I believe that's what that's going to give. So we can add. We can subtract. We can multiply by scalars. So can we put some of those together, like multiplying and adding and subtracting? So that's going to be the next sort of step. Okay. So 3a, we take the matrix that's in A and we multiply everything by 3. So it looks like 3 minus 6, 15. 3 times 3 is 9. 3 times minus 4 is a minus 12. 3 times minus 1 is a minus 3. Okay. Now I want to do 2a minus 3b. And so I don't know if you need to hear this, but the order of operations did not change, right? We're still going to do multiplication before we do addition and subtraction. So we're doing this scalar multiplication before we're doing that subtraction. So I want to take that matrix that's in A, I want to multiply it by 2. I do 2 minus 4, 10, 6, minus 8, and minus 2. And now comes the option, do I want to distribute the negative with the 3, or do I want to leave it remain? I think I'm going to distribute it and make this addition. So let's distribute that minus 3. So minus 3 to everything in B is going to give me 0. This is going to become positive 3 and positive 15. Minus 3 times minus 3 is going to be positive 9, minus 3 here, and a minus 6. And so now, if I distribute the negative, now the operation between these two things is addition. And so this is a what, 2 by 3 matrix. This thing should be the same dimensions. So we're doing 2 and 0 gives me 2. Minus 4 and 3 is minus 1, 10 and 15, 25. 6 and 9 is 15. Minus 8 and minus 3 is a minus 11. Is a minus 8.
That new matrix, the name of it is 2a minus 3b. We had to name it.
I would
Is
just
that
call
not
it.
a thing?
Yeah, you could say that, or you could just call it, give it a new name. I would call it a matrix. Well, we got A, B, C, D. I would call that matrix E. Because
Okay.
this looks more like an equation, or like not an equation, a expression to me, right?
Yeah.
It wouldn't be wrong to call it that.
Okay, but we're not going to come.
Yeah,
We're not
but,
gonna,
yeah, but it'd be a little weird to like write something as an expression and just not call it its own name. I don't know.
okay.
Maybe that's just more of a personal thing for me. I'm not sure.
Oh, I have no idea. I'm just wondering.
I would personally just call it its own thing, give it another name, E. Something like that. We got another matrix, call it F. You know.
Okay, thanks.
Yeah.
F the matrix.
Yeah. The next one will be G. Okay. Okay, so if I do something like A minus C, you can do like 1 minus 6, you can do like 3 minus 3, but after you do that, you might notice if you keep going down here. What do you notice about those two things? So one of them's a 2 by 3, the other one's what, 3 by 3? I think you're about to answer. I'm sorry, I think I cut you off a little bit there. A minus C, they are not the same dimensions. And so I talked about this a little bit before, but if you see that, You don't have to do anything. That should be like dream work right there, right? All you got to tell me is can't do that. Not possible. You can say undefined, maybe. I think was the term I used. The operation's not defined. Okay. And one last sort of thing. 2C minus 3D. Okay. Can I get both of them on here at the same time? Maybe. If I fold this over. Okay. So I want to do 2C minus 3D. So if I do 2 times C, 12, 4, 18, 6, minus 4, 0, minus 2, and 16. All right, guys, 3 by 3. It looks something like that. Now I want to do minus 3D. 3, 0, minus 3, 9, 0, 21, 0, minus 6, minus 15. And I guess I didn't distribute the negative. I just kind of went with it. So I have to subtract entry by entry. So I guess you get a flavor of each one of them. Okay. So now I'm doing subtraction. I want a 3 by 3 matrix. Subtracting correlating entries. 12 minus 3 is going to give me 9. 4 minus 0 gives me 4. 18 minus a minus 3 really adds it. 6 minus 9 is a minus 3. Minus 4 minus 0 is a minus 4. 0 minus 21 is a minus 21. Minus 2 minus 0 is minus 2. 8 and plus 6 now becomes 14. 16 plus 15 becomes 31. Ooh, can I get all 3 of those on there at once? Here we go. Double check my work. It looks like I did it right. Okay. Okay. There is one sort of thing like the book likes to do that I didn't throw any problems on the notes like, but they like to do a grayscale sort of thing. There's a problem in the MyMathLab. There's like one problem in MyMathLab that is about it. I think they do a pretty good job of just like kind of laying out how they're doing things. But if that's the point of confusion for anybody, I can definitely talk more about it. But basically, they do like a 0 is like white. I believe 3 is completely. 0 is white and 3 is completely black. And then they have like 2 shades of gray in the middle. A little bit lighter, this one a little bit darker. Sort of thing like that, you know. And so they'll have a matrix. They'll have a pixelated matrix is what they do. And basically each of these little boxes represents a number. You change out the box for a number and you have a matrix versus you have a picture. If you want to make things darker, you can always add 1 to each number in the matrix. And that's kind of how they do things. There is that sort of application that does happen. So I think it's good that they kind of include that because it shows you there are actually sort of things that we can do with matrices other than just solving systems of equations. Because I think a lot of people don't think about like the world around them. They think there's like this kind of they hold a false dichotomy between like science and art, and like there's the whole like there's that argument about left brain versus right brain, and people tend to say I'm a left brain person or I'm a right brain person, but in reality, like that is not a valid that is not a valid sort of thing to say, because most activities require you to use both portions of your brain, and like it's actually kind of a what do I want to say? It's a fallacy is what I'm looking for. I don't know how I lost that word. Now I'm just gonna hear Jesse Pinkman singing it, but it's a different story. But there's actually a sort of left brain, right brain fallacy that people often kind of invoke, and there's a lot of things you can do within art if you understand the science behind the art. And one of these such applications is like, you know, anything visual out there, anything visual you can put through a matrix. It is basically anything out there that is visual. Each thing is a pixel. Each one of those pixels is data, and we can express that data somehow. And then we can manipulate that data using different sorts of functions. Those functions correlate with things that happen to pictures, right? If you want to focus a picture, that is some sort of function happening on that data, right? If you want to sharpen or lighten, all these sorts of things that you can do with your photos, these are all just functions that are programmed into a computer. So there is some applications to this stuff, right? And so they're kind of opening up the gateway a little bit there, I think. But there's a world out there for sure. Any questions over anything we've done? I know I just went on a long rant here at the end.
Is any of that going to be on the final? I mean, this doesn't really seem that hard, actually, compared to other
This stuff,
to learn.
oh yeah, this will be on the final, so I have to include like a few problems from 6.5 on the final. And so you'll see, like, there will be, I almost guarantee you, there will be something that looks like that. Maybe not those numbers, but it'll look something like that. Multiply by a scalar and add and subtract. You'll be
Okay. Okay, cool.
Oh, do we have any more homeworks left?
So, no, not for this section. I figured y'all have enough stuff due, to be honest. So what I want y'all to do is I want you to finish up the My Math Lab stuff. Like,
Yep.
a few people are a little bit behind, I looked, but y'all definitely need to get that stuff done. I know, like, I hope you're not banking on me not filling in the zeros on those. Is what I'm gonna say. Because like some people, like if you don't do it, it doesn't show up on your grade, right? And so like some people, I don't know if that was your strategy, but you're just like, if I don't do it, it doesn't count. No, it's gonna count against you. I'm gonna fill in the zeros. It's gonna happen. Like, yeah, you got to do that homework. I haven't filled in the zeros because I can't. I got to wait till you're done doing the homework to do that. And like, the due date's not through. I meant to do it earlier at some point in the semester before I open things up, but the situation changed pretty quick, so I don't know what to tell you on
Yep.
there.
Cool.
Yeah.
There's a couple. It says you can but they're all due the 15th now. And there's a few like way back in time that I only did like, like a 95 or something on. I can go back and switch that up to 100 if I want.
You should be able to.
Okay,
If you're
cool.
not, let me know for sure. But
Okay,
you should be able to go back and work on anything.
okay.
And that's what I
Sweet.
hope. Like, I hope everyone goes back, and if you didn't do good on an assignment, go do it again.
Oh, I didn't know that. I thought.
Yeah.
Oh,
I
cool.
opened them up. You should be able to go back.
Oh, awesome.
Yep.
And that's worth like 20% of our grade.
I want to say it's 15. I'll have to look at the syllabus very quick, though.
Cool.
It's right here. What did it say? No, it's not on there. Let's see. No, tests are worth 15. Quizzes are 5. Online homework's 5, and then the written homework's 5.
Wait, say that again?
So all the daily stuff is worth 5 points each.
The daily stuff?
Yeah, so your quizzes are 5, your online is 5, and then written is 5.
Okay,
Each-
then
Each
tests?
test is 15, and then the
Oh, each test. Okay.
each,
Got
and then the final's 25. The final's
Cool.
kind of big. So I don't know I've said it like a few times already, but to study for the final, like I really suggest like going back over your test. If you got anything wrong, correct it. If you don't know why you got it wrong, bring it to class on Tuesday. Ask about it. Even if you got stuff right, you still might want to look over it. It's been a few nights. A few things have happened since the beginning of the semester.
Is Tuesday gonna be our last class?
Yeah, Tuesday will be the last class, and then Thursday, I guess I will also hold a session for y'all to ask questions. If y'all have any questions, I'll be here.
Okay.
But I guess I'm gonna hit stop on the recording since we're not doing any of the lessons.